Can everyone hear me? Just trying to do a voice test. Okay, thank you. I think there are 16 people on, so we'll just give it one more minute. At 5:03, we will start. Yeah.
Sure, sir.
Arun, is that okay?
That's fine, sir.
Yeah, okay. Okay, so let's get started because I think, some people have been waiting for quite a bit, and I really apologize that, probably we started so late. But thank you for, for attending. I just wanted to give you an overview of the way we are positioning this, webinar is that we want to showcase what is data science, and how, if you know certain concepts around data science, it takes you up that CXO career trajectory. As you know, CXO is the X can be either a chief digital officer or a chief data officer, or it could be even a chief marketing officer. So essentially what we are saying is that, in today's times where business analytics is extremely important skill to have, how do you go to, the next phase where you are someone who understands, management principles in general, and you also have a deep grounding in data science, right? So let's just jump straight into what content I had. So we'll briefly cover data science and what I think, important concepts you may need to know. Cover some of the differences between traditional and deep, machine learning. So there's a lot of confusion that people have when they use these terms. So, I thought maybe I could just cover that as well. And then talk about, some of the roles that you would typically play as you, start your career and then you get more experienced as a data science professional. And then talk about some of the details about the program we have. So I'll try and keep the balance and the marketing part to a minimum. I think there are enough people who can give you a lot of information. Our websites also have a reasonable amount. But I will just dive straight into, what is data science, right? So I think when you look at the volumes of data that has come about in the last few years, um, you know, I don't know how many of you were probably born at this time, but in the 1990s, when we started our careers, we only knew companies like SAP and Oracle, and the databases used to be what was called relational database management systems, RDBMS. These were SQL structured data, very tabular form, and it used to not take up much space. I mean, at least in hindsight, it looks like terabytes, which really I would say 10 raised to the power 15 bytes used to be very big count of storage. But fast forward to 2000s, and you have Office 365, a lot of different kind of enterprise applications which came up, which used things like images. There were videos, other pieces of files which consumed a lot of storage area in comparison to the 90s. And so you move to the petabyte scale, right? So a factor of 1,000. And then today, if you really look at omni-channel, you look at multimedia, YouTube and what have you, there are people who are generating all kinds of content, short films, advertisements, videos, a lot of media rich and storage intensive content. And we have moved to the exabyte scale. So if you really look at the number of emails we are generating daily, around 300 billion emails and 25 billion WhatsApp messages. And by the way, this was 2019 data. What all this translated into was around 5 zettabytes of data. So as I said, zettabyte is something 10 raised to the power 21. It's like basically 1,000 petabytes or 1 million terabytes. So 10 raised to the power 6 terabytes is 1 exabyte. So 5 zettabytes, and zettabytes is 1,000 exabytes. I'm sorry. So today we are generating around 5,000 exabytes or 5 zettabytes of data in 2019, and that will go up 33 times, and you will have actually 175 zettabytes of data. So why am I telling you all this? I mean, it's just like you are familiar with the exponential curve today for all the wrong reasons. Data storage is also going through that same exponential curve. I mean, the curve seems linear because it's on a log scale, right? So if you look at SAP Oracle at terabytes, there's a scale of, let's say, 1. And scale of 3 is what the petabyte is. So it's showing as linear, but it's actually a factor of 1,000, right? So we are going through that exponential curve ourselves in terms of data. And soon people will be talking in terms of yottabytes and brontobytes. I don't think anyone has started using these terms yet, but 10 raised to the power 24 is called yottabyte, and 10 raised to the power 27. So we are basically seeing so much data being created. So what is the real ramification of having so much data being created? And that I will cover when we come to the deep machine learning models, right? And why data is so valuable. Now, if we really look at the origin of data science, often people think it's a new science, right? It's been created in the last few years. That's why so many jobs have been created, and so on and so forth. But really, what has changed is that we always had data, and we had volumes of data, and all just a matter of perspective, right? I mean, like I said, terabytes used to be a lot of data. Today, it's like minute data. It's not big data. Big data is in exabytes and zettabytes. So the issue is, how do you collect data which is of different formats, which is both structured and unstructured, and how do you put it for basically being computed so that it can throw up some sort of real view or a dashboard. So it's one, the ability to collect data, organize it, convert it into a form that is, can be computed and worked on. And you have that computational power, which is also being commoditized, right? I mean, cloud capacity of compute now is a fraction of what it was if you tried to get the same capacity on mainframe, data centers even 10 years back, right? So a lot of that compute and storage capacity is now fractional of the cost it was. So this has given the ability for you to analyze data at scale, what is called big data, right? So big data is basically analyzing data at scale, or business analytics at scale. And what really is the I would say synchronization of the old practice of business analytics. I wouldn't call it old, but I would say there was a lot of statistics involved. So you needed to know things like all kinds of techniques around decision trees, random forests, linear, log regression, support vector machine, what have you, right? And the bagging and boosting techniques. But that started with very specific areas where a specialist would come in and say, okay, use this or use that. Finally, that analytics was meant to prove or disprove a null hypothesis. I mean, whoever is a student of statistics will know that everything is around formulation of a null hypothesis, and you try and prove and disprove that through statistical methods or confidence intervals or what have you, right? So what is called a p-value and all that. So the essential hypothesis that you are kind of testing is giving you an insight. So I would say the insight is what the product is of data science. So you have a lot of data which is being thrown to you as a dashboard, or let's say even a simple chart. What are you able to understand from that? And is the data rich enough to be able to pool all kinds of internal and external data to the organization to be able to give you that kind of view? And then from there, as the expert, you are able to get insight. So insight is the product of data science, right? And you use all kinds of analysis and modeling techniques to reach that view, which then you can get the insight from. So what the models do is they basically give you the view. That view, you can use BI platforms or other dashboards to give you insights. And then what you need to do is you need to understand the format of the data, right? So if you're someone who's just, knows how to load and, store files, I would say the uploading and downloading, that is not good enough. You need to understand, the data that you have. What are the fields that are missing? What is the ones where, the features are important? Which are the ones which can use to, get that hypothesis tested? So are they adequate to explain the hypothesis itself in terms of the significance, or R square or adjusted R square, whatever we have learned in statistics, right? So then you kind of again manipulate that data to be able to select the right fields. Manipulate, I mean, structure it in a form that you can then create deeper insights. So what a data scientist is really doing is they are trying to understand where I can get the best data, understand the format of the data, understand external sources where I can, make the, hypothesis, clearer from being able to formulate something and get the data to prove or disprove that, get insights, and then get the right amount of data to be able to get deeper insights. So I think this is the most critical understanding that I would expect for you to understand what really we are trying to do. The rest of the slides would be more in the form of details, and but fundamentally you should know that a good base of statistics will definitely help you, but it's not the only thing. Understanding data is even more important in this. Okay? So I'll quickly move forward. So what you have is you have three pillars. One is, as we talked about, statistical models, or traditional or deep learning models. So all these are what is called algorithms, and that's what the pillar is on top, which is data science. What is most important, and I think that was where I guess the understanding and formulation of the problem from the industry standpoint is probably the most important skill, right? So what is the hypothesis you're trying to prove, and is that relevant for the industry you're trying to prove it in, right? So how you formulate the null hypothesis itself comes from the business context. Then from the business context, you understand what is the typical data that companies who are the large or medium players collect, and which is available on their internal ERP systems or databases. And then what is the actual information you have from public databases or databases which, so for instance, simple example, right? So if you are trying to predict the output of a crop, right? It could be a kharif or a rabi crop in agriculture, right? So clearly you would have inputs related to what fertilizer has been used, how fertile is the soil, all those kind of inputs which are specific to the farm, right? But there are also things related to moisture, temperature, and rainfall. And these are things where external data would make the demand estimation so much more accurate. So that is where, if you are a domain expert in agriculture, for instance, you would know that, okay, just knowing the size of the farm, or what kind of soil is it, alluvial soil or black soil, whatever, how has been the crop yield, how has been the pest scenario, etc. But if you also know about humidity, temperature, and rainfall, which you are getting from other sites, right? So there could be something like weather data, right? So it's a famous site, and this data is paid, but you can get it off. Similarly, if you're trying to look at a marketing campaign and you look at Twitter feeds, right? So Twitter data is free for a particular number of feeds that you are trying to get external analysis based on a keyword search. So these are all things that understanding the industry and understanding the external source of data and their richness is giving you the ability to formulate the problem correctly, get the right sources of data to put into that data science model, and then get the results to be able to prove or disprove the hypothesis, and then get the insights, right? And the third pillar is really the technology, right? So this is really around ability, like I said, which is more the IT skill sets, where how to store the data, how to do version control of the models, how to do things like transfer learning. You have already trained a model, how do you get that pre-trained model back? How do you sort of use some of the specific tools like containers, or GitHub, for instance, for versioning? So all these kind of knowledge of technology is, I would say, the third pillar. But I would say these all can be learned. But what is most important here is that the business context and the data science models is probably the two most important skill sets that need to be built in a data science professional. So these are the traditional machine learning algorithms. Very busy slide, but what I'm just trying to tell you is that these things you will learn. It's not that someone who has some a priori knowledge to maybe comes from a statistics background or a math background or engineering, let's say computer science background, or even, let's say, operations research, right? A lot of the people, mechanical engineering or operations research people, have a lot of insights into a lot of these areas. But that is not what is required as a prerequisite for being a great data science professional. I mean, you have to really understand the industry very, very well. I mean, I remember in my first job, I was an investment banker in Merrill Lynch, and I thought knowing M&A and all kinds of techniques around mergers and swap ratios and valuation and worksheets was the most important skill set required. And I went to the first day on my job, and I went to my boss and I said, okay, I can do this, that, etc. And he said, just go and understand the industry, don't do anything else. So if you are like, I was covering cement, so he says, just understand how cement is produced, right? So you go and understand how a clinker works, you understand what are challenges related to cement. It can't be transported over long distances. What is OPC, PPC? why cement cannot be exported, so on and so forth. So you have to understand the industry thoroughly. And that was the most important skill in investment banking, where, you have to be productive on day one. So I can tell you, all those various things that people might be telling you that, okay, I know how to do, naive bias classifier, or I know how, boosting and bagging techniques work, is a temporary advantage. These all will be taught as specific, theory in the courses. So essentially, there are 4 types of broad classification of ways we solve problems. So there is what is called supervised learning techniques, and there is unsupervised learning techniques. So supervised is, you have a training set of data which have output labels, right? So you know that, okay, if something is like this, output is 1. If something is like this, output is 0. So you have a label which is 1 and 0 for a set of data where you already have the information. Now you're trying to see whether you do it on a new set of instances, let's say what is initially the testing and validation data, and later to the real world scenario where you want to see whether ones and zeros, what comes out, and machine should be the model should be accurate. So those are what is called supervised learning. So they come under prediction. So you can predict what is the value of, let's say you have a set of data points, which is a scatter plot. Can you draw a line through that which minimizes the error, and you can predict what is the value going forward, right? So those are the regression models or the prediction models, right? So with the best fit kind of line, which could be linear, non-linear, it could be a log scale line. The other is what I mentioned earlier is the classification, right? Whether you classify the output as 1 and 0 based on previous data you have. And then you have a set of unsupervised learning things, which is unsupervised learning techniques, which is essentially things like association, anomaly kind of detection. So something is seeming out of place, can that give an alert even though you don't have training data, even though you don't know that something is kind of going to be a fraud or something which is unusual? Can the system throw up that anomaly? There is also something like clustering analysis where, through k-means or nearest neighbors, you can actually work on something where you are able to cluster points together based on where points are situated close by. And you say, okay, these kind of people think similarly. There's also something called market basket analysis, which is, what the rule of association is. So you know that someone who is buying brown bread and bottled water are, rich people. And someone who's buying white bread and fruit juice are different kind of people. Maybe they are value conscious people or middle class or what have you. Someone who's buying curd and sugar are similar, so maybe that is part of their staple diet. So, so those kind of things, right, which the association rules give you based on where those items are mapped based on data you collect, right? And this also gives you the ability to be able to position things. So if someone is buying curd, you might want to position sugar, saying that, do you also want to buy sugar, right? Because you know that people who are buying curd also buy sugar, or, this kind of thing like sanitary napkins and beer and, all those kind of things which are there, case studies and Target and Walmart. So what I'm just trying to say is that there are a set of supervised learning techniques and unsupervised learning techniques. All these will be taught in the course. It's not something that you need to come in, prepared. But what I'm just trying to say is that there's a lot of learning. Principal component analysis, for instance, tries to make data less complex. So for instance, if 3 or 4 features, like we say features are, what is trying to explain an output variable, right? So these are x1, x2, x3, trying to explain y, right? So y is equal to x1 plus x2 plus x3. If you're trying to kind of say that, okay, x2 and x3 are actually related to each other and they're not explaining y more, then can I remove x3 and just have x1 and x2, right? So this is what principal component analysis tries to do, is that it tries to make things more simple so that you can get more value from that data. And this would only come when you have that understanding that, look, the R square is not going up. So why am I continuing to use more number of variables where, if for instance, x3, the value of the data is not available for a lot of the, data points, then I'm just, causing errors in my model, right? So those are things where understanding the data, understanding the interpretation of correlation between X2 and X3, and using techniques like principal component analysis, you can do a lot more with that analysis, and your value builds up when you are able to put this all together as a data science professional, right? So I will skip this slide, but I'm just trying to say this is pretty much what I talked about, which is the supervised, unsupervised, and all the things that you probably need to know, and these are forming part of the traditional machine learning algorithms, right? And then there is something like what is deep machine learning. So you have heard of neural networks and artificial intelligence and whatever, hidden layer, multi-hidden layer models. You could have heard of CNN, RNN, LSTM, GAN, all these kind of terms, right? So what do they all mean? Right? So these are all deep learning models which are saying that, look, if we are able to create a model of a system, which is, let's say, a set of compute nodes, which mimic the nodes of or the specific nerve centers of our central nervous system, and they're all like sensors which are collecting data points. Is there a way we can mimic? So for instance, when we see the computer, it just takes us 0.01 second to guess it's a computer, right? But there is so many inputs that are involved in that decision, and it's just that our system has got trained to understand that this is a computer. But if I were to see something completely new, I would take some time to assess what it is, right? So what deep learning is trying to do is mimic the human nervous system, where you are able to train that network with certain ways in which it gets simulated by seeing certain patterns, what is called edges and curves, and based on that, you're able to come up with a conclusion that, okay, this means this is the object in front of me, right? That may be relevant to what is called convolutional neural networks or image recognition systems, which is how the brain operates based on sensory signals sent from the eye. But it could also be about perceiving speech, like what we see Alexa and others. So how is it able to understand my accent, understand what I'm trying to search for, and then give me the relevant results, which could be some songs or some sort of knowledge that I've sought from it, right? So if I say, okay, how many positive COVID cases are there? How is it able to understand my accent? How is it able to understand what is COVID? How is it able to query the internet or the information systems and get the right sort of output to me, saying, okay, today it is 14,000 for India, right? So those kind of things are what RNN or LSTM model um, kind of reinforcement learning, kind of, which is the most modern deep learning technique, is trying to kind of do based on the use case. And you would also need to have that understanding of statistics, because it all comes together, right? Because if you know only deep learning, what you're essentially doing is you're trying to throw data at a system, trying to train it, and playing around with some what is called hyperparameter. So you're trying to change one of 7 parameters and trying to get a result which is I mean, you don't know what will work and what will not work, essentially. And if you have that good understanding, experience, you've worked on similar projects in the industry, and you have a math and statistics base, or you're taught that in the program, you are able to do so much more. So the difference really is, when you look at deep learning, it's something which is very iterative. It has to be programmed. It uses data to come up to a state where now it is able to recognize things, for instance, speech or image. It does not require expertise from human beings, like stat experts or someone who's trying to interpret the output of a regression model. Okay, what is p-value or adjusted r square, or what have you, right? So all the beta values of the equation itself. So this is where I would say deep learning is sort of different from traditional machine learning, and the accuracy can be as high as 98% for images, or let's say 92% for speech, right? So for human beings, as an example, it is 75%. So for instance, someone from Africa were to hear someone from US, 75% time he would be able to interpret what the person from US is trying to say, right? Because accents are different and what have you. But if you were to do that for a machine who is, let's say, trained on the accent of person in, from the US accent, he's able to get it right more than 92% of the times, right? So that's the kind of, I would say, accuracy that deep machine learning models have, which is, really a huge improvement even compared to human beings. So these are more around, neural networks. There's so many. So RNN, like I said, recurrent neural networks, it's right up there. You have LSTMs. So these are pretty similar, but, LSTMs also have a memory component. So you'll see the same nodes, which will have, an inner circle, which says that I'm able to retain it. So when I'm having a different set of data that I'm trying to retrain the model on, I haven't forgotten what I've learned in the previous training set, right? So that's the only difference, but otherwise the architecture is the same, and they're used for speech and natural language kind of scenarios. You have, what is called feed forward networks, so they don't have a backward feed, what is called back propagation. You have all these kind of, Boltzmann machines, Hopfield networks. These were actually machines which, or models that we used in the early 90s. I mean, when I was a student trying to, use these models in my project as an engineer, I was using Hopfield net. So these are definitely not new. They existed probably from the 70s. And there are enough papers. If you go and do your research on the net, you'll find enough papers about all this. So what I'm just trying to say is nothing is new. It's just that, as I said, compute power and, ability to manage data at scale. I mean, for me to train a model like that used to take 2 days. I had a 486 machine, which was the previous version of a Pentium. To train a simple network used to take 2 days, right? Today, it'll come in fraction of a second. So that's really the difference. Similarly, if you look at, some of these other kind of models, don't bother too much. I'm just trying to kind of say that, this Cohen network was what I worked on in the 90s, in 1992. And, today, you have moved on to a lot more complex networks, lot more hidden layers, a lot more kind of stuff, right? Which ensures that, you're able to create a stable set of weights, right? Which also are able to, like the LSTM network, kind of do that. When you look at networks like GAN, right? Generator adversarial networks, you have two of these kind of networks which are working against each other to find out who's able to converge faster or give more accurate results, right? So you're having those kind of models also, like the competitive element has also been brought in. So these are why they are adversarial, because two networks are working against each other to see who wins, right? So anyway, so long and short, there are enough models that are there, and there's huge learning. This is the last real, I would say, detailed slide. I just wanted to tell you there's something called MNIST. This is a data set of handwritten symbols. All this come as 9 by 9 pixels, or 28 by 28 pixels into this network. And like here, so you have 28 by 28. This is capturing the image of one object, right? So if you take this leftmost O, that is being represented by this 128 by 28, and 1 is the number of channels. So then this goes through this whole set of hidden layers, right? So what is called, convolution. So there's a set of filters which is trying to go and read this entire set of O, which is very grainy data, and trying to put it as edges and curves, as I said, and then move that forward, and then it gets pieced together, and then it kind of gets output either as 0 or one of these, right? So ideally, any of these symbols coming in, you want the output, which is this fully connected layer, to highlight whether it is 0, 1, 2, etc. So the accuracy is any of these symbols gets classified as 0, etc., etc. When I was talking about 98% accuracy for image, it means that 98 of these images have been classified correctly in the right class, right? And that's what, you know, these networks are. And just look at the number of lines of code, right? I mean, I had to write almost 200 lines of code in C. Today in Python, you can write maybe 20 lines of code and do exactly what this is, you know, supposed to do, right? I mean, everything is pre-built in libraries. You know, you have all these kind of libraries which give you what is called NumPy and all that, which give you all the ability to convert an image into a sort of, you know, output through a fully connected layer, and all the weights are adjusted based on all the libraries that come in here, right? And for instance, if you divide by 255, any image can have value from 0 to 255. When you divide that, you're basically making all images have a value between 0 and 1. So that enables the stability of the network, right? So you're not creating something that artificially keeps jumping up and up because something is getting reinforced, and then you have an unstable output, right? So all these are inbuilt into, you know, the code itself, right? Okay, and this is RNN. I'll just skip this slide. This is, you know, where you're actually trying to get this snippets of the wave. As you know, the speech is a wave form. Every 20 milliseconds, you're trying to get a sort of sample of data that goes into this RNN, and then you're classifying it with probability that, okay, what that person said was A or B and so on. These are letters, but then into words, right? So then that becomes much more complex, where this RNN, which is trained, and the language, which let's say has US accent, is able to kind of get this bits of data and classify it into the right word. So the person said, you know, farm, or that person said hope or something, you know. So all that is a combination of this, right? So these are all sort of what RNN models do with, you know, LSTM and RNN, piecing together signals to be able to detect words with a probability of likelihood kind of thing. Okay, and then reinforcement learning. This is the most modern kind of thing. Has any of you heard of AlphaGo? So I'll keep it slightly more interactive. Have you heard of Go or AlphaGo, which is a machine that was that defeated Lee Sedol, who was the global champion? Have you heard of Deep Blue and IBM, computer, which defeated Garry Kasparov? You must have heard of Garry Kasparov. We are in a country of chess, grandmasters, right? So Garry Kasparov was the one who was the reigning world champion in 1987 or 80s. And IBM created this machine called Deep Blue, which defeated Garry Kasparov. And this was the first time that a machine defeated a reigning global champion, you know, who obviously, you know, is the brainiest person when it comes to chess, right? So that was a precursor, but that model took almost 6 or 8 years to create, you know, where you are trying to kind of work with all kinds of chess moves, understand, you know, what is the right move. You're trying to predict how this move will go going forward, etc., etc. And then reinforcement learning created that 8 years to 4 days. So there's a company called DeepMind, which is acquired by Google in 2014. It has data scientists who earn close to $1 million. I'll repeat that, $1 million salary per annum, right? Why are they paid $1 million when, let's say, IT support people or IT service people get paid, you know, $10,000 or $15,000? It's because of the value that those people created by creating something which was probably 10 raised to 3 times complex as chess in 4 days versus 8 years. I mean, can you imagine how technology has evolved, right? And that was created on reinforcement learning. So they created this RL model, which actually defeated, and the model had to play 1 million games by itself, right? And then they had this real model which was able to understand what is the cumulative reward, where it can probably come up with a favorable outcome. So that was the sequence of current state, what action it needs to take, and what is the reward it will get for that action. iterate this for the next 50 steps, right? Because a game typically would get, so that is called the episode, right? Whatever, till the end of the game. Or it could be infinite. And you measure the sum of the rewards to maximize it over a period of time. And that was how it was at every step able to understand that, okay, for the next 50 steps, what is the step I should do right to be able to beat an opponent? And based on the state, which was the current state of all the buttons which were there on this board, which was infinitely complex and far more complex than I wish I had a picture of that. But yeah, I mean, it's like, yeah, it's like checkers with a lot of, small items on the board, and there's infinite ways in which you can move that piece, right? Now, this is really, I wanted to, because business analytics, business intelligence is used in the industry and almost synonymously and the same way as data science. So I just wanted to tell you that, look, the difference really is that in business intelligence, it's like a output from the ERP, right? So last quarter, what are the sales, profit, what went wrong, why did deliveries not happen, so on and so forth. So this is like more like a report, which could be standard report or ad hoc report. Yeah, which is sort of trying to give reports to the manager in a company, which helps them take the right. Yeah, request everyone to go on mute. I think some people are on unmute. So if you have a question, please just type it on the chat, right? Otherwise, it creates a bit of turbulence for everyone. So standard and ad hoc reporting is what comes under business intelligence. So you'd have heard of platforms like Cognos, or business objects, or Tableau, what have you, right? Click, and so on. So these are all business intelligence software, right? What they do is basically they just get the data from the actual model or the business analytics layer, and they publish it in a form that managers can understand and read. It's not in geeky form. And what the manager has to do is basically look at those charts and say, okay, this is what we need to do right this quarter or this year or for our budgeting, and so on and so forth, right? So these are all based on structured data which resides within the organization, right? And what is data science doing? We covered that in the first slide. It's going beyond the enterprise level data. It's going to unstructured source of data. And it's trying to, the data scientist is trying to pull out additional data which would be meaningful. Like I said, when you have rainfall, temperature, humidity, that weather data, if that can be helpful to a farmer or agricultural organization which is doing farming, what is that additional data that I need to get, which may be in an unstructured form? I have to make it quasi-structured and unstructured, and then get it in a form like video feeds, right? I mean, how can I understand video? Today, from a YouTube video, can I recognize a cat, right? Can I recognize a cat when my model is trained with a lot of cat images, which is the supervised version? Or can I recognize a cat from, just some unsupervised model, which is what is the frontier of machine learning today, that from a video, can I recognize humans or objects and those, so on and so forth, if that has not been part of what I've been trained on? And where is this useful? Let's say an autonomous car. If the car has a lot of camera sensors and accelerometers and what have you, it knows all the parameters related to the car. But what is ahead? If I've not been trained that this is a lion, because I've been trained only on city data, and banging that lion would cause a loss of life. Or so someone is going in on safari in Kenya, and this is the autonomous model which has been force fitted on that that buggy, or something like a tree that if I have not been trained on tree data sets because it's not part of a common this, but I've been trained on lampposts, can I assess that the impact will be the same and I can cause damage and it could cause an accident and injury to the passenger? So these are all things that unsupervised learning would be so much better than a trained model which just has limited number of objects, right? So how many objects can you train on? That is why that data took 8 years for IBM to train that model on all kinds of moves that a chess master makes, and then beat Gary Kasparov, right? So that need not be done, because if I'm able to create that view of what is the future, likely scenarios, understand probabilities, assess the maximization of reward, which is what the reinforcement learning model did, I can actually perform well without needing to be trained for 8 years, right? So this is the difference. Huge scale of data, external data, and stuff which will be iteratively becoming better over time, right? So that 98% accuracy doesn't happen with one model or one training instance, right? It's something that has happened over a period of time. It's not a Kaggle competition. It's something that, let's say, has kept getting fine-tuned with the data scientists saying that, oh, okay, this is what's working, not working, and over a period of 6 months that model has been trained to become 98% accurate, right? So again, what is the class of bins of analytics problems? Like I said, it's prediction, forecasting, customer lifetime value, right? If I have to understand this is the cost of acquiring a customer, I need to understand what is the lifetime value of that customer, right? So that is what the prediction model teaches me. Classification is something where I can understand whether this customer has a tendency of churning out. He's a value customer, but very not loyal kind of thing, right? So should I spend a lot of discounts and additional cost on this customer, or should I be spending time on another customer who's more loyal, right? So that's all about customer churn, which a lot of telcos and banks are doing. Similarly, risk. If I'm trying to give a new personal loan to someone and I don't have his credit history, do I know his payment records for his credit card bills or other things which I can churn over a period of 5 minutes to take a decision that I can give a loan at 12% instead of 14%, because this customer is going to be high credit worthy, or less credit of less risk kind of customer, right? So how do I do that dynamic modeling of interest rates, or making an offer at all to a customer based on 5-minute kind of analysis by checking CIBIL scores or credit payment history or any other tendency which gives me an inkling of how prompt this customer is in paying back. Similarly, fingerprint matching, that you do on your screen, it's not done on image recognition, because that will take probably 10 minutes. If you're trying to recognize the fingerprint in 1 second or half a second, there is something called the valleys and peaks of your finger, which gives a capacitive value, right? Because there's a capacitor. So that is recognized and it's unique to you. And that's what, let's say, Samsung and other people who are, giants in electronics are using a mix of, machine learning and, hard, pure electrical engineering to kind of come up with these kind of innovations in smartphones, right? So those kind of things. Recommender systems, like I said, if you have association based systems, or what is called market basket analysis, what Flipkart is doing, can it recommend the right kind of product to someone so that they buy more, right? Or I can sell 4 books instead of 2 books or 1 book, because I show something that is recommended. The offline version of this is when you go and check out in any bookshop or general superstore, you have a lot of books, chocolates, a lot of things lying around close to the counter, right? So what they're trying to say is that, okay, if you're tempted to buy a chocolate or some other coffee table book or something, that's the physical equivalent of a recommender system, right? So I incite people to buy more. Similarly, if you go to Big Basket or Flipkart, they have something called, are you sure you want to check out, because have you bought everything, right? So they are trying to remind you that if you bought curd, have you bought sugar, for instance, right? So those are what recommender systems are trying to do. And that also minimizes the supply chain cost, because if Big Basket is to deliver to your house and they have to deliver in 2 tranches, it's doubling that cost of transportation to you. And we all know cost of transportation is 30 to 60 rupees. I mean, and this is a cost they don't charge you. So why would they pay another 60 rupees because you didn't check out the sugar, and they need to make that delivery again to your house, right? And optimization is what is the modern machine learning techniques is really around the traveling salesman problem, which is, the vehicle routing. How do I minimize the same problem, right? The last mile problem. How do I give the package to the right person who's doing the delivery? Let's say, Zomato or Fresh Menu guy, so that he can make minimum number of trips. So you minimize the petrol consumed and the maximum packages delivered. The metrics all around that, which is solved through the vehicle routing problem. And there's bin packing, which is around how do I minimize what I have to supply in the minimum number of trucks, right? So if I have a standard truck capacity, how do I put what I have to supply, given that there's limitations around the dimensions? It could be a cylinder, it could be odd shaped item, it could be very small items. So how do I, ensure I've packed in maximum items and I minimize the number of trucks, right? And there's something called knapsack packing, that I have one truck. How do I maximize the value of items which will give me the maximum profit or give me the maximum customer satisfaction, whichever way you choose it, right? So these are all real world problems that are being, done through these kind of models in telecom, banking, retail, what have you. And so if you look at the framework, the initial problem is domain understanding. You do the problem and identify the problem in a very tight manner. So what is the model supposed to give you, right? So that has to be very clear. So the definition of problem, and that's where your domain knowledge is so important, right? You're not a statistics or IT person trying to, solve this problem without having that domain understanding. You're a one-man army, or one-woman army rather. And then you go and collect the relevant data. Like I said, it's a very iterative process related to the data. So you understand the features, you understand the quality of data, you understand what is the external data available, you get that. You do the pre-processing. Like I said, you move it from the unstructured form to semi-structured or a quasi-structured data. And then, this data can also be fed into the same model, gives you some kind of, additional ways of making the model more intelligent, and then it gives you a more accurate output, which is what you're after, right? Deeper insights, which is what the data pre-processing needs to keep doing. Then you select the model, and this is really, I would say, 20% of the task, right? 80% of the task is the first 3 steps. And everyone who goes into a data science job says, oh, okay, data pre-processing, all this should be done by the IT guys or, some other guy, but frankly, if you have that knowledge, that is what is helping you do this 80% of the task in 60% of the time. And then you can spend more time in the iteration of the model and create something which is of more value to your employer or your startup, depending on where you are, right? And then you kind of deploy the model into production, because once the model is fully fit and ready to be productionized, then you have to kind of see that it works in scale, and then it has to be run by a separate team. You are the operations people, the machine learning operations people, who have to run the model on an ongoing basis, because they are the ones who are providing that input to the the relationship manager, whether to give a personal loan or not, right? So when they want that model to give the outputs, the operations people get involved to support that frontline staff to be able to make those decisions. So this is really the kind of tasks that really get done, and this is the framework. So if I were to look at the path to CXO, I know we are going slightly over time, but I thought I would just elaborate it more, because then it's more relevant, rather than really answering specific questions which may be more pointed and specific to a few people. So here, when you do those 5 framework models and you have that deep understanding, you go into a data engineer kind of role or a business analyst role, depending on where you're coming from. If you are more management oriented person, you become someone who understands the requirements of the customer, what is called a business requirements gathering person, or a product manager, or something like, from that aspect. And then you feed it to someone who is doing the more intensive data intensive task. But someone coming out from this course can be able to straddle both roles equally comfortably, right? So you're doing the data pre-processing, as I said. You have to have a exposure to one or both of these languages. I would say R from a data science perspective and Python from a machine learning perspective are both equally important to know. So you should have a good familiarity with both those knowledge languages, and then you're good to go. Modeling, yes, I mean, some understanding of the stat models, but I would say, this is something that you don't need to have a statistics or a math background. And then visualization, because your output should be able to go straight to a decision maker. And that I mean, someone who's a business P&L head, because, you are someone who's anywhere at a managerial level. You're not someone who's, just someone at the back office who's trying to, just run or churn out models. So you're someone who's at the management layer, but you are someone who's not taking that decision. So you have to help visualize that output for a decision maker. And you also need to have that knowledge of querying, right? How do you do SQL queries? How do you do macros in Excel? How do you understand NoSQL databases querying, right? The JSON queries, API creation to other data sets, so that you can get data moving. So these are more the technical skills that are required to be able to fit into this role. And I would say between 0 to 4 years you would typically be in a role. You could be called senior data engineer or principal data engineer, but primarily you're doing the same kind of tasks. Then you move to a project manager role in 4 to 8 years, where really don't bother about manager or director or all that stuff. It doesn't matter. What is your role as a function, not your designation to the outside world, right? So so you are essentially managing a team of people who are the 0 to 4 year people, and the function deep enough so that you can assess the realistic time frame they will take to do their bits of work, because otherwise everyone will take you for a ride. So they will say it'll take me 3 days, but actually it could be done in 1 hour, right? So the rest of the 2 days, these people are taking it easy because you have agreed to them taking 3 days to produce that output, right? So you have to be very much familiar with these techniques, understand with the resources they have, how long it'll logically take them to do this task. And then you should be someone who understands a deeper aspects of the machine learning models that work, because these people may be more oriented to using the same kind of models time and time out. Can you be their guide saying, okay, no, don't use this kind, use XGBoost, or use a neural network for this, because I think it could get done far easier and far faster, right? So you're that guide to also giving them the right techniques when they get stuck, right? So that's the application view of the machine learning models. And if they get stuck with some kind of error, can you guide them? So that saves a lot of time, right? Because otherwise these people say, look, machine is throwing me this error, and I really don't know what to do. IT guys are not supporting me, so what do I do? So you should be able to step in and basically sort that problem and make this person more productive. And that's really what the project manager does. And then you move to a project executive role. So you're a partner in a consulting firm in data science. You have something where you are able to visualize the customer problem as steps in a process. So you create what is called really a design thinking, a journey map for the customer, and you basically help the customer decide which are the problems he should sort out first, and help him get the quick wins. You get the confidence of the customer, then you decide a roadmap as to which problems you can do in 1 year, which problems will take 3 years, and you're like that trusted advisor to the customer, right? Who the customer is relying on to be able to create that cutting edge data science model, basically solving his problem. He really doesn't care whether you're using neural networks or traditional machine learning or some simple regression. He's saying you solve my problem, right? Business problem. So you're the one who's basically taking it to the right level of details with your team, which is the people in the top two boxes below. And then after you kind of cover that role, you kind of are on the path to CXO, right? Today, you don't have the person coming from outside who's some, VP engineering or something from a different industry, like Silicon Valley, coming and taking a CXO job. See, today, there are very specific types of data that is available in Indian context. And if you have had that view with various clients in a consulting organization, or if you are part of being the partner of data science in that, retail company, let's say Target or Walmart, can you sort of then become the chief digital officer or chief data officer of of Walmart or Target, or you are sort of like that senior partner in let's say Mu Sigma as an example, right? So this is the path to CXO, and today it all comes from deep understanding of really the domain and data science. And you have to ready yourself for 10 to 15 years in this line, right? Because if you are spending so much time on a program, spending some money, you are understanding how problems in this area are solved, which are the most exciting problems today. You have what is called a T-shaped skill, right? You have the broad management layer skills where you understand what is marketing, finance, HR, what have you. But you also understand that in marketing or in um, a specific, let's say, operations research optimization problem, what is the kind of algorithm to use and how to get the right data for it, right? So all that, if you've spent 12 years of your life or 10 years of your life, that is when you'll be a success. Because if you basically after 2-3 years feel that, oh, this is too mechanical, or this is too boring, or this is something that I don't enjoy, then it's best not to get into this area at all, right? So that's where I guess you have to be very excited. I mean, I have 23 years of experience. I like I said, in 90s, where I used to be a student at IIT Bombay, I did a machine learning project, and I would have been one of the pioneers if I had continued in a technical line. But unfortunately, I went and did an MBA, and became a consultant and investment banker, and then so on and so forth. So I've done a lot of loops around different industries, but I would say that that's probably the wrong thing to do today. If you are excited with this line and you kind of go and do this MBA in data science or do a master's in data science and go down this path, you will be a rock star 10-12 years down the line. Today, there's a person called Andrew Ng or Jeffrey Hinton. I don't know whether you've heard the name, right? These people were my vintage, but today they are called the father of artificial intelligence in the world, right? In the world, University of Canada. Then they went to Google and so on. So these people are sort of today cutting edge because they have remained in the field for 23 years or 25 years, what have you, and they are masters in the game, right? So long story short, be very clear that this is something that interests you at least for 10 years or 15 years, where you can then reap the advantage of data science, right? And then final thing is really that don't use data science and business analytics or business intelligence interchangeably. Now you know the difference, hopefully. Data is the most important thing. It's not really understanding models. Understanding of data is more important, and if you have wrong data in, your models will never work. And business context is something that you need to have, and which is where the management and strategy and understanding of business is so important for someone who's trying to be a rock star of data science, right? If someone comes from a computer science engineering, very, very narrow focus on statistics and machine learning and deep learning and so on, that person may not be super successful as a data scientist because the business context is missing. And that's where I guess I'm coming to the next part of this, which is, why is it necessary to have IFIM and Insofi, who's our partner, tie up, right? Because IFIM is a business school with a 25-year track record. I don't want to bore you with the details, but we were the 6th business school in India to get a AACSB accreditation. You can go ahead and Google AACSB and see, what is. So I think only 10% of the business schools globally have a AACSB. It's a global certification. It's not something specific to India. Some of the IIMs were before this. So obviously having a disruptive curriculum was part of that. So we wanted to make people who are industry ready. We didn't want to create people who are theoretical and did case studies of the 70s and 80s. I don't want to name some of the IIMs, but unfortunately that's the way they teach. They want to create fundamental strength, but they haven't changed their case studies over the years. And then if you look at InSophie, and yeah, clearly we are trying to create T-shaped professionals. Hopefully you understand what that is, which I've alluded to. So you have the set of skills around, all the core business courses. You will have projects. So you are, ready on day one on the job. Your boss doesn't have to send you on a training program. There are other things like, improving your personality, your speaking skills, presentation skills, sports, fitness levels. You work on socially relevant projects, and so on and so forth. And you work with industry mentors so that you are all ready with, this horizontal part of the T. And the vertical part of your T is what we will do through the data science specialization with, projects and major and minors, which is where InSophie comes in, right? InSophie is our partner. They are the number 3 ranked data science school in the country. Probably this was 2018 by Analytics India magazine. I think they should be in the top 3 or top 2 in 2019 rankings. Why are they, good? I mean, you would have heard of, 20 institutes, right? Jigsaw Academy, Triple ITB, lots of, programs. I don't want to sort of really talk about others because I really don't know what their strengths are, but I'll tell you the strengths of InSophie. InSophie has 23 professors who have the best PhDs from US universities, which could be Carnegie Mellon and Johns Hopkins and Ohio, Cincinnati, Ohio, and so on and so forth. These professors have all been, toppers in IIT in India, and they have moved to do their masters and PhD abroad. Some of them were my classmates, 2 of them actually, and then these professors have actually worked in industry. They have not been just working in academia, solving problems for academia in US. They worked on Wall Street. They worked on various other institutes to kind of bring that global learning to the Indian context. So if you look at any program that any US business school would teach as part of data science or advanced business analytics, whatever you call it, right? IMA, it's called advanced business analytics. Wharton might have a different name for it. It could be different for a university in Australia, New South Wales University, or Wollongong, or what have you. The issue is that the strength is the closeness to industry by the professor industry and the kind of projects which are industry ready, right? So this is what InSophie brings. 23 professors. Can everyone go on mute, please? So it has these 23 professors who are PhDs from the US, 1 professor from ISC, and 45 data scientists who will guide your actual project. So how do you ensure your project is deep enough? It's something complex for the industry, not just for getting a grade. And who supports you in that? So these are the data scientists who are, again, people who are doing this day in and day out, right? So they support you to ensure your projects are complete. So I would say, both these bullet points are extremely important when you select, who is going to teach you deep data science skills. Okay? And like I said, they are all people who come from startups, or, they work for Target or other kind of, very advanced organizations who on real world problems. And again, there's a hyper specialization among people. So it's not that someone is called just machine learning professor or deep learning professor or so on. You would have that broken up into RNNs, LSTM, like I said, text mining, NLP. You would have things like structured data, unstructured data. So I'll come to that. You have people in blockchain, Dr. Praful Chandra, who teaches blockchain, and so on and so forth. So like I said, these are the kind of people who will teach you from Carnegie Mellon, Johns Hopkins, so on and so forth, Sunny Buffalo. Dr. Murthy is the founder of InSophie. He himself teaches courses that shows you, the kind of focus these people have on learning and teaching, right? And Dr. Sridhar Pappu is the co-founder. So these are the people who have started this institute. You have people, like I said, Praful Chandra, who teaches blockchain. He runs a blockchain startup. So if anyone who's cutting edge in blockchain, it's this gentleman. You have people who are, worked in in Frankfurt in real life, deep learning AI projects. You have people on structured data. Like I said, Rohit Lotlikar is a classmate of mine, all India rank 48 in IIT JEE. These people can get anything they want, right, from an academic standpoint. But he worked in IBM research for 20 years. He's worked on creating the kind of problems which were solutions for real services industry in India. And he's worked in India for 20 years in IBM research, like I said, and, very, very brilliant sort of people, right? And my classmate in IIT Bombay. And Anand Jayaraman was, like I said, a person who was, again, a classmate of mine, worked in Wall Street for 18 years, and now is teaching market research, financial markets kind of specialization for this process. So to get these kind of people, you have Dr. Venkatesh, who's the dean of the program. Again, he used to be a vice president at Vodafone. He's going to be an expert in IoT, teaching you, and there's someone on supply chain and so on. So you'll get a good mix of skills for all kinds of digital supply chain, whether it's the physical side or the software side. Blockchain, like I talked about. So blockchain and IoT is very, very hot in the industry. If you want to focus on finance or finance MBA, algorithmic trading, what Dr. Anand Jayaraman would teach, and so on and so forth. So this is what I mean when I say top-notch data science faculty, right? And then when it comes to the institution, like I said, you have a lot of the sort of badges which showcase that this is a program that is very well recognized, right? So it's not only AACSB, there's SACS, and we also have people from AICT, which is the nodal agency on our board of studies, right? So that can give you the kind of comfort that this degree is going to be recognized by any postgraduate institute in India. And these are the kind of employers. So these are, of course, subset. So we have 300 employers from IFM side, and maybe 500 from Insofi side, which are focused on data science and management. So these are the kind of people who would hire. DXC, as you know, is HP, the earlier services business. Flipkart, of course, everybody knows. Target, Walmart, Amazon. Because retail, banking, and telecom problems are the ones which are the most dominant, requiring deep learning, machine learning models, right? So this is why some of these employers are what have you. So what I will do is I will probably let you ask some sort of question, and and maybe if you have anything specifically that you want to ask. I'm just saying that people with different years of experience will get into different roles based on that value of that experience coming up. And this course caters to bachelors of any discipline who are not scared of math and statistics. I mean, if you're scared of math and statistics, don't even do it, because like I said, if you have to stay in this industry for 10, 12 years, you should not be hating your job on year 3, year 4, right? You should be someone who carries it through and becomes that partner or CXO. And that's what this program is targeted. We are not trying to create deep machine learning capabilities which a computer science program or a master's program or a PhD program can create, right? We are trying to create people who will be managers of those PhDs, who are on their track to be CXOs or chief data officers or chief digital officers. Yeah, PGDM in data science. I'm sorry, I'm not going in any particular order. Is there any difference in selecting major in data science and minor? Not really, because the course will pretty much, the choice is really the stream, whether you choose finance, which is financial markets, or digital supply chain, which is more optimization kind of problems, or there's something on healthcare as well, right? So we have got those 3 streams of specialization. Of course, there could be more, as we also have partner institutes like Texas Austin and others which are coming up, which could give you more into marketing analytics or HR analytics and so on and so forth. It really doesn't matter. You can choose your credits. Of course, a standard MBA program requires 30 credits in the major area and 10 credits in the minor area. So you have to select the subject, so on, but nothing prevents you from auditing any of the other courses if you have time and the inclination, right? So, and everything is on video, etc. You can pull those videos and watch it in your at your study time or leisure time. How is it different from PGDM? Business analytics? Like I explained, what is the difference between data science and business analytics or business intelligence? Huge difference, because you're now tackling data at scale. Maybe now business analytics could be like advanced business analytics could mean the same as data science. Like Ahmedabad runs a program for people with more than 4 years experience, called advanced business analytics. Their average age is around 10 years experience. So that's called advanced business analytics, probably around the same, right? Impact of super specialization on COVID-19. Look, I think if you're looking at super specialization as an on-site program, I would say next 6 months is going to be tough. But for people who are coming in now in July batch, their super specialization will kick in next year, July, right? So obviously you have a year to go. For those who are taking a short-term program or something which requires, travel in the next 6 months, I would say difficult. But if you look at all the current techniques and the fact that it has become interactive, I would say the experience is almost the same. See, if you have this superstar professor from Texas Austin or Darden or ESCP or our partner universities, Rennes or so on, and you are getting them to talk to you on an interactive mode, then it really doesn't matter, because they will anyway come and give you a case study and tell you, okay, can you present as a group, right? So if you can do that on online media, the only difference is spending a couple of lakhs more on travel and physically being in the US. So obviously I know, I mean, traveling abroad is a big thing for Indians, and especially people who have not traveled earlier. So definitely that is something that may be a negative for the next 6 months. But if you're looking at it as a program starting in July, I don't see a problem, because next year everything is back to normal in my view. I could be proven wrong if it's a black swan that extends. But otherwise, no impact of COVID-19 for the batch starting now is the short answer. Beside Python, what are the programming languages? See, don't treat it like a understanding of programming languages. When I was in engineering, I was trying to do C, C++, all the languages that existed that time, Java and all. But today, if you really look at it, it is the way of you, understanding how to break up that problem into one, incorporating libraries which already have those subroutines which are doing what you want to do. So for instance, if you are trying to do some sort of complex function, if it is available in NumPy or SkyPy, all you are trying to do in Python is import NumPy as NP, right? Input NumPy as NP. That's 4 words which you need to know about anything else, right? If you are kind of looking at object-oriented programming versus functional programming, yes, you need to do one of each. So if you do Golang or you do some other functional programming languages, yes, you need to do that, because for blockchain, that kind of languages become important. But for object-oriented programming, for instance, if you know Java or C++ or any of the other languages, Python, it should be pretty much the same. If you are a backend developer who is trying to look at optimization, then Python may not be the right language. You might need to know C, right? Something which is closer to the kernel or machine language. But that is as a programmer. But for data science, I would say R and Python is more than enough. And Python also is in 2 modes. One could be use of your terminal, where you are a more experienced programmer on IPython, or using Jupyter notebooks, where you have a menu driven user interface, where you can easily put that code into something where how to run it. It's like a Visual Basic, right? You have a standard screen which you know how to operate. It may be slightly less efficient, but does the same task. So I would say all that can be learned. And Python, between Python 2 and Python 3, I mean, yes, you should go to Python 3, because really that's the de facto standard, and Python 2 will be sunset. But as long as you're on Python 3.5, 3.7, you have a knowledge of R, and you are downloading this latest version of the R upgrades, you should be good. It's very easy to learn, and you don't need to really bother about programming. You need to bother about business context, have 3-4 industries in your pocket. So let's say for me it was automotive, telecom, and cement. These 3 industries I know back of my pocket, right? And that was my job in investment banking as well. I would cover clients of that sector. So in this case, you have to cover clients who are in these industries. So say your specialization is retail. So you as a consultant would be covering Flipkart, Amazon, and Target, and Walmart. So pretty much everyone who's using big data, right? So retail is a very important industry to specialize in, I would say. Supply chain is a horizontal. So you need to know everything around optimization to some of the visibility aspects, where you need to know blockchain, IoT. So that those kind of skill sets would need to come in, where you need to know API management, you need to know how to do robot programming, IoT, those kind of things, right? So that is something which is more a supply chain kind of specialization. Long story short, if you do the program that is done, you would be able to really cover a lot of real industry problems. And you really don't need to bother about it today. It as you go forward and do the courses and do the the basic projects, you would understand which are the ones which are of interest to you, and then you could choose your specialization and subsequently super specialization in those areas. So it's very evolving. Don't worry about it. Even my son is studying data science now, and I've just put him onto a course. I said, just understand SQL programming and R, and later you will figure out what you want to do in data science, right? So don't bother about it. Yeah. So PGDM finance student, like I said, financial markets could give you a job into asset management. So for instance, if let's say Templeton or Kotak or ICICI Prudential is hiring, they want someone from data science area who is someone who's up and running, understands how to, let's say, do modeling, where they are able to help the traders, or let's say more fundamental investors for more the longer term funds, choose which are the kind of stocks which are less volatile, have high beta, have those kind of things. So all that is something which are part of your financial markets course, in how to select stocks. So you are giving that input as a data science expert to someone who is a fund manager or a CIO, who wants that advice, because in his folio he wants to get these kind of stocks with specific characteristic, and get out of the volatile stocks, or get out of mid cap and get into large cap, but he doesn't want to go into a stock which is not moving at all. Like if he goes to, just giving an example, as Indian Oil or GAIL or something, he does not want to get into that stock because it's not moving at all, but he wants to get into HDFC Bank, which is performing great year on year. So I'm just saying that can you differentiate from picking out market information for the last 20 years of the BSc or NSE data, to be able to give him that kind of inputs, right? So that financial market specialization is making you a finance professional, but it's making you specialized so that you can get picked up by these kind of companies. They don't want a general finance MBA who understands random walk theory, or how let's say general balance sheet looks like, or how you do asset liability balancing, or you let's say even do investment banking. So you do an investment banking course, but that tells you all about terminology, but you don't have a project which is teaching you how to kind of go about doing this kind of assessment of which stock or which startup will do well, or which is the kind of company I should go after, either in my business development effort or supporting a team which does that. So those skill sets, which are ready skill sets for the market, is what probably that T-shaped skill will help you differentiate yourself from a general finance MBA. So hopefully that long answer helped answer that specific point you had, Akash. certification course, see, with this PGDM, we are also giving you a PGP certificate, right? That PGP certificate on its own is giving you these jobs. So you can imagine how, whether you need any other certificate or not. This certificate of PGP from Insofi plus PGDM, which is MBA in data science, full-time course, is being given to you. So what I'm just trying to tell you is that it's a dual degree in some sense, right? It's an MBA plus PGP in data science, and that gives the employer comfort that you are able to look at things from a management standpoint. You have some specializations in particular industry. You're also able to get your hands dirty by creating models and giving outputs which are understandable by management people. So the visualization part, and you also have ability to be a future manager, right? So you are on the management track. So that is what this program gives, and probably similar programs like this, which probably either which is being offered by a business school or being offered by organization like IIITB, may not be able to cover both aspects. Is my understanding. What is the benefits of working in data science field? So initially, I think the kind of jobs you will get will be, in my understanding, 10 to 15 lakh bracket, right? So what would a general MBA get in today's market? They would get something, general MBA, I'm not talking of IIMs, maybe IIMs is slightly higher, but it would be in the 6 to 10 lakh bracket, right? That's my view. So I don't want to pay much for a generalist. I want to pay for that one person. See, you hear all these things about, one person being hired by Morgan Stanley in New York for 1 crore salary, one person being hired by XYZ organization at, $200,000. Why are those people getting those jobs? They are just picking one person or two people, right? It's not that I'm McKinsey, I know IIM Ahmedabad gives me the best MBAs. I will go and hire 5 of the top 10 students, and I'm sure that these 5 students will basically survive because they are the top 10 in a batch and they have gone through all those rigors, right? So it's a very different play. I'm saying I'm someone who basically has budget to hire one person for 1 crore or $200,000 or whatever, right? I'm not really bothered about the number. I talked about DeepMind, right? Why were those data scientists being paid $1 million of salary? That's 7 crore rupees per annum, right? Why are they being paid 7 crores? And these are not very senior people at CXO level. These are people who, let's say, have 7-8 years of experience. That is because those people are really cutting edge in terms of creating that go beater in 4 days. I mean, which people, like, so for instance, today, if we have to get reinforcement learning to create a antivirus for COVID, what is the one algorithm which will create those, number of iterations, which will, fine tune with all the data I have? See, of course, you have to get the data from, human trials and, animal trials and all that. Assuming that that is available somewhere with H1N1 or anything else, one person can be able to pull the right data sets, like, which were the kind of people who reacted to whatever chemical you're trying to test for H1N1 or bird flu or SARS or whatever. And drug can be put out in the market. That drug will earn, few $1 billion, right? Today, every country will pay you $1 billion of buying that drug. So which company will sort of be the first to market with that drug, where they have a 10-year patent or 15-year patent, and using data science skill sets? So, you can imagine the scale of the problem that the data scientist is trying to solve. And you look at anything else that any other manager is solving today, no one is doing anything which is at this scale. Maybe with the exception of someone in blockchain who is like trying to create the next blockchain network on, for alternative banking or something like that, right? That was incidentally my role in IBM. I used to be the practice leader for blockchain in IBM. And our role was to go to a state government and see if we could work on a pilot with a government to do any sort of ways of, digitizing land records or driving license, or anything to do with solving, digitizing, and making something tamper proof and secure, right? So what I'm just trying to tell you is that if you are at that level in the organization, that's where you'll earn that kind of salary. Okay, so don't look at things like general MBA, manager, VP. I was a VP in 4 years in Merrill Lynch. Did that VP have any value? I mean, if I go as a 4-year experienced guy and say I have a VP on my card, does that really add any value to you? Everyone knows that you're like a VP from Citibank who's coming in, and you still have to wait outside for the big guy in Citibank to give you time, right? So anyway, long story short, I think just try and look at all these kind of aspects in data science. And what we can do is we can, if look at any other questions you have, or, conclude this. If there are any follow-on questions you have, just, probably reach out to any of the counselors who have been in touch with you, Shonali, or anyone in that team. And if you feel that there is something that requires really something that you need urgently to make up your mind whether one course is better than the other, or something related to anything in data science, then you can just, put that in this, right? Just give me 1 minute, please. Sorry, my next call started, and yeah. So I've left my email ID for all the people on this chat, and you can reach out to anybody, get clarifications why this program is good or another program is good. And like I said, we are also alumni of IIM Ahmedabad and everything. So I can tell you at least about the IIM equivalent programs, which are the programs which are good or not so good. And even related to maybe some of the other partner programs we have. And I can tell you a course which costs 10 lakhs is equivalent to 30 lakhs of value for any international program, giving you a similar scale of, let's say, salaries that you would start earning with 1 or 2 years of experience. Immediate salary, I'm not sure, because it's the first batch which will pass out next year. It's a compressed 15-month program. So, 15 months full time, you have to do that. It's not, 24 months. And you come out with it as a T-shaped professional, ready to solve an industry problem and ready day one on the job. So I'll leave you with that message, and thank you for joining. Probably I've addressed some of your queries. Anything else, please send me an email. Happy to answer. So I will close the call now. Yeah. Thank you very much.